Okay, hello. This is the first video for Chapter 1A. In this section, we're going to go ahead and describe 1-1 and understand points, lines, and planes. Now, points, lines, and planes should be straightforward. In this case, I'm just going to describe each little description of each one. So, undefined terms is one of the things that geometry is used, one of the most basic forms of geometry. So, what are they? So, there's only 3 of them. So, it's points, lines, and planes. Now, the way that these are usually described in geometry, or the way we are seeing them, is that there's always, for points, it's always just a dot. It's always a dot with a capital letter. Okay, so wherever you see dots, then it's most likely a point. Now, with lines, what you notice is that there are 2 dots. 2 dots will always make 2 dots connected together. Will always give you one line. Okay, but in this case, they both have arrows at the end, which means that the line keeps extending for forever in this way. Keeps extending forever in this way also. Now, the notation for a line can either be a cursive letter like this one, like L, or it could be M, a cursive letter W, or if it just says like 2 points at X, Y, then it should just be X, Y. Okay, with both of the arrows going in different directions. All right. So for planes. Now, the ways that you're able to describe a plane, it can either be just another cursive letter. So in this case, it will be M, and in which case it will be called plane M. Or you can just pick out 3 points that are on the plane and put them together. So we have plane A, B, C. Okay, so that's just one of the ways of actually describing all 3 of these undefined terms. Don't forget, it's one of the basic forms of geometry. Now over here, we have segments. Now a segment is just a partial part of a line. It's not necessarily a full line that's extending for forever, just like we have over here. It has like a little part of it. Okay, so when you think about segments, think about a piece of a line. So over here, we have points. We have points A and B. Now, the way you're able to write the notation of all this, so all these right here, that's a notation for a point. This is a notation for a line. This is notation for a plane. This is another notation for a line. Now, notation for a segment would be capital A, capital B, and then a bar on top of it. Now, the A and B both are what we call endpoints in this case, are both endpoints. So that's why they have the arrows right here. They're both endpoints, and they're both at the end of a single line. They're all at the edge. They're the very last points on the line. So it could either be AB bar or BA bar. Okay, so the way you read it will be segment AB or segment BA. Okay, so pretty much a segment is made up of 2 endpoints. Okay, now another case where we can use an endpoint is where we're working with rays. An array is just primarily just an endpoint that extends out and it's going through another point, and that line just keeps going on for forever. So an example here, say you are at point U and you're trying to go through point Z. So I was just trying to think of the ways like U as in you and then Z as a zombie, so you're facing towards a zombie, or you're just trying to take out the zombie. So you go ahead and point towards the zombie, try and take him out. So just the arrows right here. So it just a ray is made up of an endpoint and another point and an infinite line going in that direction. Now an opposite ray. Oh, and it's the way you write the notation for this one is you could go ahead and put them both together. So UZ with the arrow pointing to the right, just like this. So opposite rays. Opposite ray looks just like a line, but it has a point kind of in between both 2 endpoints. So right here we have ray UZ. So we go ahead. UZ. And we have ray UN pointing in the opposite direction. Okay? So those would be two rays that are opposite of each other. Okay, now you see that one's pointing the opposite direction of the other, and they both form a straight line. Okay, now they will always make a straight line. They will never be curving like a 90 degree or making an L shape like this, they'll never do that. They will never do that. So it's always a straight line going across. Now, the word collinear is another word we worked with. Now, collinear just means that we have 3 points or a certain amount of points that you're figuring out, and they both or all of them make up a straight line. They're all part of a single straight line. So if I would say here, we have the straight line here. We have line, I'm gonna call it line M, and we're trying to determine whether K, L, M, and D are collinear. Then the only ones that are collinear here are K, L, and M. All these are collinear. Now, if we were to say if K, L, and D are collinear, then that wouldn't be true because D is not on the line. Okay, so LM is collinear, LK is collinear, KM is collinear, and all these three are all collinear because they're all on the same line. Now, if you were just trying to add on the D, then it wouldn't make it collinear. Now, coplanar, all it is, you have to have points on the same plane, just like we have over here. Points A and B and C are all on the same plane here. Okay, now if I were to make another point here, and we'll go ahead and call it point E, then point E will not be coplanar with all these points because they're not inside of the plane or on top of it. Okay, so that would be it for coplanar. So we will say that E is non-coplanar with ABC. Now, what else is there? Let's go ahead and just work with a couple examples I have here. Now, right here we have points, lines, and planes, and we have to understand points, lines, and planes, and that'll be section 1. Now, right here we have our plane. We'll go ahead and call it plane S, and we have all this stuff. Now we're asked, what is the name of the plane? Now, by default, we should already have plane S. So we'll go ahead and call it plane S. Or we can call it, what else can we call it? B, E, or A. So we'll go ahead, plane BEC, sorry. So BEC, BED, or we'll go ahead and go with BEA. Okay, so we're focusing on this one. Now, identify a line segment on this figure. What would be a line segment on here? What would be a piece of a line? So you can go ahead and say BE is a segment of it. So BE, or what else? AC. What else? Would ED be a line segment? No, it wouldn't, because they're not connected. Okay, so that will be it for those two right there. Now, that will be it for that one. Now, these set of problems. So we're asked to identify an array on this figure. Okay, so identify array. Where can we see array? Where can we start at an endpoint and head towards one single direction? So we can go ahead and call C as one of our endpoints. So C, and we're pointing towards point D. So we can use that one as an endpoint. Another one we can use is use the same one and call it C, and heading towards B. Or we can use C heading towards A. Or we can call, oh, that's about it. Okay, that's it. So these will be all the arrays that we can come up with. Now, 3 non-collinear points will be, what else? BCD will not be one because they're all on the same line. We can use BCA, BCE, DCA, or just a couple examples, so we can go ahead and use BCE. Okay, so use them in commas, so BAC, commas. So you can go ahead, wait, I'm running out of time, so I'll see you in the next video.